Ray marching is a method of finding an intersection between geometry and a ray by incrementally stepping or marching across the ray. The most common ray marching algorithm for rendering is called sphere tracing. Object distance functions are used to determine how far a point in space is from the nearest object. The ray can then be marched by that distance without intersecting inside an object. This is repeated until the distance becomes small enough to be considered an intersection. Shadows can be implemented by simply casting another ray from the intersection point towards a light. If an object is intersected before reaching the light, the pixel is considered to be in shadow, otherwise the pixel is illuminated. This is a 2D example of a simple render using ray marching. Moving into a 3D render using ray marching, the shadows cast can be realistically softened with a simple equation which adds very little computational expense to the algorithm. As the shape of objects are defined using sign distance functions, fractals can also be rendered using ray marching. A skybox is implemented by sampling a cube map using the ray direction vector as a UVW coordinate. Mirror reflections are implemented by creating a new ray upon intersection in the reflected direction between the ray direction and the surface normal. Diffused reflections are implemented with a post-processing pass using a compute shader, which blurs the reflection based on the surface roughness. Other modifications to the surface material can be made, such as changing the surface colour. Ray marching allows for reflected objects which are off-screen, such as the torus, which can be seen even though it's behind the camera. This implementation of ambient occlusion is a computationally inexpensive method which uses the number of steps taken to provide the ambient occlusion effect. Ray marching enables real-time Boolean operators for no additional computational cost, except for the cost to render the second object. The demonstration in the video is a sphere being subtracted from a Julia fractal. I hope this technical overview of my ray marching renderer was interesting, and thank you for listening.